Welcome to the Architecture Corner. Today we're diving into something that feels like it could be a real solution for a pretty common headache in cloud architecture. You know those times you're carefully building out your microservices, your serverless functions, everything's looking good, and then bang.
Yeah.
You hit that spot where you just need to connect A to B.
Oh, yeah, definitely.
And suddenly you find yourself writing, line after line of what everyone calls glue code. These little scripts, maybe tiny Lambda functions, their only job is just shuttling data, maybe tweaking it a bit, sending it on.
Right. And it often feels brittle, doesn't it? Adds overhead. It's just, yeah, it can be a real chore.
Exactly. Well, get ready, because today we're going to unpack a really interesting development from AWS called EventBridge Pipes.
Mm-hmm.
And this isn't just, another service. It seems like it's really designed to bring some elegance, some real efficiency to those tricky integration points.
That's the goal. Yeah.
Yeah. So our mission today is to give you a super clear understanding of this tool and show you how it actually uses a concept that's almost 50 years old from the Unix world. Can you believe it? 50 years.
It's amazing how these ideas cycle back, isn't it?
It really is. We're leaning heavily on a great article by Mario Bittencourt here.
Yeah.
And I'm really curious to see how these, battle-tested concepts keep popping up in our modern cloud services. Let's dig in.
Let's do it.
Okay, so EventBridge Pipes. The name itself, pipes, makes you think as, pipelines. But what exactly is a pipeline in that foundational sense, the one that EventBridge Pipes is apparently building on? It feels so basic, but maybe overlooked.
It is absolutely fundamental, and I think that's the beauty of it. The core idea of a pipeline, it's a way for processes to talk to each other, inter-process communication, right? And it's been a key part of Unix-like systems since, way back in 1973.
Wow, 73.
Yeah, and think of it simply. You've got a series of programs, maybe two or more, linked by this sort of metaphorical pipe. The really crucial bit, the thing that changed things, is that the output from program 1 just automatically becomes the input for program 2, and then its output goes to 3, and so on.
Like an assembly line.
Exactly, like a really efficient assembly line, but for data, each station just does its one specific job.
Right. And this connects directly to that whole Unix philosophy, doesn't it?
Right.
Which is where it gets really interesting. It's all about those small, super focused programs. Each one does one thing, it does it really well, and then you combine them, and suddenly these simple little pieces working together can pull off incredibly complex stuff that, one giant program probably couldn't do as reliably, or you definitely couldn't maintain it as easily.
Precisely. And for us, working in the cloud today, that's not just about, elegant design theory. It means systems that are easier to debug, more resilient, and honestly, it reduces the mental load for developers trying to map out these complex data flows.
Yeah.
So if you connect that philosophy, breaking down big tasks into smaller, manageable, reusable bits, well, that fits the modern cloud environment perfectly, doesn't it?
It really does.
AWS is essentially taking this time-tested idea and applying it directly to serverless and event-driven setups, giving us a standard managed way to chain services together without needing all that custom, often fragile glue code.
Okay, it abstracts away the boilerplate, lets you focus on the actual business logic.
That's the idea.
That makes a lot of sense. So, okay, how does EventBridge Pipes actually take that classic Unix concept and make it work in today's cloud architecture? How do these pipes function in the AWS world, moving beyond the theory?
Right. So EventBridge Pipes lets you set up these pipelines with potentially 4 different stages, which gives you pretty fine-grained control over how your event data flows.
Okay, 4 stages.
First up, you've got the source. Pretty straightforward. This is where your event comes from initially. Pipes supports quite a few common AWS services here. SQS queues, DynamoDB Streams, Kinesis Streams, Amazon MQ, even things like self-managed Kafka. It's just the starting point for your data.
Got it. Source first.
Then, stage 2, there's the filter. Now, this one's optional, but it can be incredibly useful.
Okay.
It lets you look inside the events using the same EventBridge event pattern syntax you might already know from setting up rules on an EventBridge bus.
Right, like matching patterns.
Exactly. So only the events that actually match the pattern you define get to move on to the next stage. It's sort of like having a really smart bouncer for your pipeline.
I like that.
Yeah. It only lets in the events that actually matter for whatever comes next. And that's not just, a neat trick. It means you're not paying to process events or sending events downstream that the next service doesn't even care about. That's a real win for costs and just keeping your architecture clean.
Yeah, definitely avoids waste. Okay, so source, filter, what's next?
Next is the enrich stage. Also optional. This is where you can actually modify or add more information to an event before it goes further.
Ooh, interesting. How?
Well, you can configure the pipe to call out to other services, maybe hit an API gateway endpoint or trigger a Lambda function, or even call a synchronous step function state machine.
Wow. Okay.
And the idea is to pull in extra data, maybe apply some business logic, transform the event somehow, basically make it richer before it moves on. This turns a simple pipe into more of an intelligent data processor.
Right. Adding context makes sense.
And then finally, stage 4 is the target. This is simply the destination for any events that made it through all the previous stages.
Okay.
The end of the line.
Exactly. And again, Pipe supports a whole bunch of targets. Currently over 15 different AWS services, things like step functions, Lambda, SQS, SNS, other EventBridge buses. Lots of common destinations.
That's quite a few options.
Yeah. And one other neat thing, both the target stage and the enrichment stage support something called input transformation.
Input transformation. Yeah, it means you can actually reshape the event data one last time right before it gets sent to the target or processed by the enrichment service. Maybe you need to flatten out some nested JSON or pull out specific fields or even add some static values.
Oh, so you can make sure the target gets exactly the format it expects.
Precisely. It takes that burden off the downstream service.
Yeah.
They just get the perfectly formatted data they need.
That's a game changer, isn't it?
Yeah.
Having those filter and enrich stages built right in.
Yeah.
Without needing, like you said, custom lambdas for every little filter or transformation rule, that just simplifies things massively.
It really does.
It's not just cutting down the code, it's the whole operational side too, right?
Yeah.
Thinking about patching, scaling those little lambdas, cold starts, managing their dependencies, separate deployment pipelines.
Yeah, all of that overhead potentially just goes away for these common integration patterns. It's a big win for developer experience and for keeping the system reliable.
Okay, that's a really clear picture of the stages. Source, optional filter, optional enrich, target. Now, to really get the impact, let's walk through a real-world example. How would this actually look? Because I bet a lot of you listening have stared at a diagram thinking there has to be a cleaner way to get data from A to B without writing another Lambda.
Absolutely. Let's take a really common one. Imagine you've got a service using DynamoDB for its data storage, and you need to let other downstream services know when things change in that table. Maybe new orders come in, customer details get updated, inventory levels change, whatever it is.
Okay, standard stuff. DynamoDB changes need to go somewhere else.
Right. So the traditional way, you'd probably enable DynamoDB Streams on your table.
Yep.
Then you'd write some custom code. Usually these days it would be a Lambda function triggered by the stream, or maybe an older style worker pulling the stream. But let's say Lambda. That Lambda function reads the changes from the stream and then pushes them on to, say, an SNS topic so other services can subscribe.
Right, stream-lambda SSNS. Seen that pattern a million times.
Exactly. But even for that simple flow, that Lambda needs its own runtime deployment package, IAM permissions, you need logging monitoring. It has its own life cycle. It all adds up, even for a simple task.
It really does.
Yeah.
Okay, so how does EventBridge Pipes change that picture?
Well, this is where it gets elegant. In the absolute simplest pipe setup, you just define two stages, the source and the target.
Just two.
So your source is the DynamoDB stream, your target is the SNS topic, and that's it. All the change records from your DynamoDB stream get passed directly, completely untouched, to your SNS topic.
Whoa.
So if a new item gets created in DynamoDB, any service subscribed to that SNS topic just receives the full DynamoDB stream record for that item, JSON format, exactly as it came from the stream. And crucially, you didn't write a single line of that Lambda glue code to move it.
No Lambda at all.
None. AWS manages the connection, the data transfer, the error handling between the stream and the topic. It's just a pipe, a direct managed pass-through.
Okay, wow. That immediately shows the value. Just taking out that one little Lambda function removes a whole deployment unit, something you have to monitor, configure. It's instantly cleaner.
Right out of the box. For that simple integration, it's more efficient.
But okay, what if you don't want to send everything? Like you mentioned single table designs in DynamoDB earlier, which are super common. What if that table has orders and customers and products all mixed together, but your SNS topic downstream only cares about, say, the orders? Sending everything seems wasteful. The downstream guys would have to filter it out themselves.
Exactly. And that's the perfect use case for bringing in that optional filter stage we talked about.
Ah, the bouncer.
The bouncer, exactly. So instead of just source-target, you set up source-filter-target. The filter stage looks at the data coming from the DynamoDB stream and only passes forward the events that match the pattern you set up.
Using that EventBridge syntax again.
Yep, the exact same powerful EventBridge matching syntax. So if you only care about orders, you could create a filter pattern that looks for records where maybe an attribute called type inside the event data is equal to order.
Okay, that makes sense.
And the Pipes handles the rest intelligently. If the source was SQS, it would delete messages that don't match the filter. For streams like Kinesis or DynamoDB or for Kafka, it just advances the offset past the filtered out messages so you don't reprocess them. It can even handle decoding if your source data is encoded, like base 64, before applying the filter. Though you got to make sure your filter pattern matches the source format. JSON source needs a JSON filter pattern.
Gotcha.
But the result is only the order events make it to the SNS topic. Everything else is quietly dropped by the pipe itself.
So that's like a double win then. You're removing the filtering logic from your own code, simplifying that downstream service.
Yeah.
And you're saving costs because you're not paying for the pipe to process irrelevant events, nor are you paying for SNS delivery, nor are the downstream services consuming useless messages. It's efficiency and cleaner architecture.
Exactly. Cost savings and architectural purity all in one optional stage.
Okay, this is really clicking now. We've got the basic pipe for simple routing and the filter for being selective. But let's push it one more step. What if the data coming from the source, even if it's the right type of event, isn't quite what the target system needs? Maybe it's missing some key information or it's just in the wrong structure.
Right. Another classic reason for writing. Yet another Lambda function, right? Just to fetch some extra context or reformat things.
Exactly. Does EventBridge Pipes have an answer for that too?
It absolutely does. And that's where the third optional stage, the enrich stage, comes into play. This is where arguably the true value of pipes really starts to show for more complex flows.
Okay, tell me about enrich.
Let's stick with our DynamoDB example. You've filtered, so you only have order events coming through. But maybe the target system, let's say it's a downstream marketing automation tool, needs more than just the raw order data.
Okay, like what?
Maybe it needs to know the customer's current loyalty tier or their preferred contact method or maybe their geographic region to tailor the marketing message. That info isn't likely in the order record itself.
Right, it's probably in a separate customer profile somewhere.
Precisely. So in the enriched stage of your pipe, you could configure it to invoke, say, a specific Lambda function.
So Lambda can still be involved in a very targeted way.
Exactly. The pipe passes the filtered order event to this enrichment Lambda. The Lambda takes the customer ID from the order, uses it to look up the customer's details, maybe from another DynamoDB table or an Aurora database. Wherever your customer data lives, fetches that loyalty tier, contact preference, etc., and then it returns that combined enriched data back to the pipe.
Oh, I see.
The pipe then takes that fully enriched event and sends that to the final target our marketing system.
So the marketing system gets everything it needs in one neat package. It doesn't have to make its own calls to the customer service or database.
Correct. It significantly reduces the complexity and the dependencies on the consumer side. The pipe handles orchestrating that enrichment step.
That is really powerful, especially in a microservices world where you really want each service to stick to its core job, not constantly be fetching data for other services.
Yeah, it helps maintain those boundaries much better.
Okay, so pipes seem incredibly useful. Are there times when maybe a pipe isn't the right tool? Or where perhaps a more traditional EventBridge rule on an event bus might still be the better choice?
That's a really good question. They are powerful, but yeah, not a silver bullet for everything. One key difference is that an EventBridge rule can easily route a single event from an event bus to multiple targets simultaneously.
Fan out, right?
Right, one event triggers several different things. Exactly. A pipe, by its nature, is more linear. It's designed for that point-to-point flow. One source, through optional filtering and enrichment, to one target. If you need that one-to-many fan-out, a standard EventBridge rule is probably still your go-to.
Okay, that makes sense. One-to-one with steps versus one-to-many.
Right. Also, think about the complexity of your enrichment. If the logic you need is super complex, maybe it needs to maintain state across multiple events, or it involves very long-running processes. Well, trying to cram that into the enriched stage of a pipe might not be ideal.
Yeah.
Pipes are really best suited for relatively quick, stateless enrichment lookups or transformations. If you need something heavier, you might still be better off having the source trigger a dedicated step functions workflow or a more robust Lambda function directly, rather than using the pipes enrichment stage.
So evaluate the complexity. If it's connecting A to B, maybe filtering, maybe adding a bit of data pipe is likely a winner. If it's a complex orchestration or fanning out everywhere, maybe stick with rules or step functions.
That's a good way to think about it. It's another tool in the toolbox, and knowing when to use it is key.
Absolutely. Okay, this has been fantastic. We've covered a lot of the surprisingly old roots of the pipeline idea, the core stages of an EventBridge pipe, source, filter, target,
Yeah.
and then really digging into that powerful and rich stage. We saw how it simplifies common scenarios and adds intelligence without lots of custom code. So boiling it all down, what does this really mean for someone trying to build more efficiently, more elegantly in the cloud?
Well, I think what's really fascinating, as you said, is just how much operational complexity and all that boilerplate code can just disappear into a managed service.
Yeah.
For those simple integrations where you definitely would have written some glue code before, EventBridge Pipes offers this direct managed alternative that immediately cuts down your operational load. And like we discussed, the filtering brings immediate cost savings and cleaner event flows. Enrichment lets you do sophisticated data prep without making downstream services more complicated.
It's really about building smarter, isn't it? Letting developers focus on the actual business problems.
Exactly. Focusing on the higher value logic. The insights from Mario Bittencourt's article really drive home how much you can streamline things by embracing these kinds of managed pipelines.
It really seems like a potential game changer for event-driven architectures.
Hmm.
Okay, so here's a thought for you, the listener, to take away. Think about your own projects. Where do you have that glue code right now, just connecting services? Could a simple EventBridge pipe maybe streamline that, make your architecture cleaner, more resilient, maybe save you some money and maintenance headaches? What new things could you build if you didn't have to worry about managing that translation layer yourself?
Good question to ponder.
Definitely something to think about. Well, thank you so much for joining us on this look at EventBridge Pipes. We really hope this gave you a fresh perspective and some concrete ideas. You can find more information and links in the episode description. And hey, don't forget to subscribe, absolutely free, to the Architecture Corner newsletter over at architecturecorner.substack.com. We do more deep dives into interesting tech topics there all the time.
Yeah, check it out.
Thanks again for tuning in, and we'll catch you next time on the Architecture Corner.